Uh, yes, you can see here, this is my ATAL profile. Your attendance you can see here, and then you can see assessment here. In this tab, you will get an assessment link here. You have to click here, and after you check this, and these are the instruction, you can start the test here. Now, as ma'am said, please note the time. Because of the timer, you won't be able to take the test again, I mean second time, or you won't be able to appear after 7:30. So please take care of that. And the feedback is here. You have to fill the feedback form here, and it will be provided in the ATAL portal itself here. They will provide it here. They will enable the link form here. And if these three things are done, then you can find your certificate of FDP here. Uh, you can see here the criteria has been mentioned that you have to submit the feedback form. Your attendance is required 80% or above, and you have to give the get the marks in the test 70% of above. Then you can get the certificate, download your certificate from here. And if it is not available due to certain technical issues, then you can contact us after 3 days. So within 3 days, they will make your certificate available here. But if it is not available, you can put the query in the WhatsApp group. We will provide you the certificate. So this is how you have to attempt your test here and fill the feedback form here in the ATAL portal itself. So if you have any
query,
yeah, ma'am. Yes, if you have any queries, then you can uh, talk to us today. And the schedule of tomorrow will be from 2 p.m. So please take care of that. Instead of 6 to 9, we have 3 session planned for tomorrow. That is from 2 to 3:30 first session. Then from 3:30 to 5 second session. And from 5 to 6:30 there will be a third session. And we will appear for exam at 6:30 to 7:30. And then there will be a valedictory session. So please take care of the timing for tomorrow.
whether today's Madam, please check whether
Ma'am,
the
your
expert has joined.
yes,
Yes, yes,
ma'am,
right.
we are waiting for
Kindly.
expert.
Okay, okay. So let me call him. Just a minute. Okay, all participants, please wait for 5 minutes. Expert will join us within the 5 minutes. Please have a patience here. That is joining.
Good evening. Am I audible? Sinal, what do you say?
Yes, sir.
Okay, great. Thanks.
Sir, just wait for a minute.
No worries.
Okay. So, good evening, everyone. On behalf of GEC Modasa Computer IT Department, FDP coordinators, and entire team, I warmly welcome you all to the AICT ATAL sponsored 6 days online FDP program from data advancement in data science and machine learning from concept to applications. So now we will begin the first session on ensemble methods today. And it is my privilege to welcome and renowned academic leader and technologist, Dr. Rakesh Vanjara, sir. He serves as a Dean and Faculty of Engineering and Technology at GLS University, Ahmedabad, and brings over 25 years of experience in education. An alumnus of IIT Roorkee, he holds the professional credential including the CEH and ISO 27001, lead author, and is a senior member of IEEE. And his work spans the cybersecurity, auditing, and consulting Gen AI technologies, always focused on responsible and real world impact. A passionate educator and innovator, he is dedicated to advancing the education and technology, driving student success, and shaping future ready engineers who are technically skilled, ethically grounded, and globally competent. So please join me in welcoming Dr. Rakesh Vanjara, sir. And now I would like to invite sir on behalf of GEC Modasa for the session. Sir, the session will be yours now.
Fine. Okay. Thank you for nice introduction, and I hope I'm
Yes.
audible to everyone, right? So I will be
Yes,
sharing
sir.
my screen, and in between, if some glitch is in the connectivity, please keep me updating. So I will be sharing my screen, and just let me check once it's get visible to you. So I'm sharing an entire screen for a moment. It looks a bit odd, but I don't have any other option. Okay, fine. So are you able to see my screen now? Probably. And there is a
Yes, sir.
right. So there is a QR code in front of you.
Yes, sir.
So if I request all participants to scan it, if you have a mobile, just scan it. And there are two questions. Just go through it. Yeah, great. So just scan the QR code, and there are two questions. Just try to answer. Right. So I got one person answered. So you have got two questions, right? The first question, I think it's visible to everyone. Great. You just need to scan the QR code. And I can see there are almost 70 plus participants, but I don't know. Okay, great. Maybe you can open the camera and you can give it. Second question, you will get it now. Yeah. Those who are not able to see the QR code, it is for them. Again, just you need to scan the QR code and fine. So second question, right? Which situation signals the high variance? Okay. So now, I think I should not discuss much because there are many participants who are not able to probably get into. I don't know the reason. So I'm going to my presentation now, and I will answer why this question is very important for all of you, right? Okay, great. So I'm moving to my presentation now. Just give me a second. Uh, I think now you are able to see the first slide. Uh, Simple yes will help me because I have put it in presentation mode, so I cannot see you. Somebody has to speak out. Are you able to see the slide?
Yes, sir, but it's loading.
Uh-huh. Fine.
Yes, sir, it's visible now.
Now, just you tell me. Is it full screen now or no?
Sir, it is full screen, but we can only see
How
loading screen.
blank screen is visible right now, sir.
Sorry.
Black screen is visible. Loading is written in text.
Okay.
Presentation is not visible. Now visible.
Now visible, so I'm not able to go to the slideshow. No worries. I think the screen is visible now, right?
Yes, sir.
Yes, sir.
Okay, fine. So the first point is, let's say if you had a 3 week student solving a problem, right? And would you trust just one or ask all three and combine their answer? This is the question, and most of us are faculty over here, so probably you know the answer, right? So we have seen this in the classroom, like individually, each student might make mistakes, but when you ask the question in the group, probably they are able to have a good estimation of the answer. So same thing, I posed the two question, and probably if you look at the answer where most of the people have answered, so probably that answer would be the correct one, right? Similarly, if you look at the second slide, I hope something is in front of you, some very interesting, the picture. So this experiment done in 1906, and let's say we are doing it today in 2025. Can you guess the weight of this photograph? You know, can you weight the photograph of this ox? Yes. Just you can write somewhere in the chat. I don't know whether you can write it or not, but you must have a chat facility, right? Great. So can you just again? I am showing my presentation. Uh, can you just guess the weight of this picture? According to you, what could be the weight? Just guess a number in kilograms. Yeah. Okay. Somebody written. Great. 180. Okay. Fine. 180. So, great. Fine. Oh, 200. That's great. Great. Go up. Go up. Good. Great. Great number. Okay. fine, but okay, fine. Somebody is very close, but somebody is very far. So what this experiment was done, and they asked 800 people to guess the weight, and then what they have done is they've taken an average of that, and probably that was very close answer, right? I know that here we have a very less number of people, but still, if you do that experiment, probably the answer would be almost very close, even though not exactly. So, what is the real world scenario before I jump into my topic? You know, whenever there is a critical decision has to happen, they will generally make the batch of the judges, right? They don't leave it to one judge. Similarly, the medical second opinion, it's a very well known. Even sometimes the people like me, right, if somebody even said the typhoid, I will prefer to go to the second doctor who will say probably a no, right? So that's always what we do is, right? So in medical also you do the same things. And even in buying a cloth or buying a mobile phones, we it generally depends on a lot of opinions. Even nowadays when you go to watch a movie, or let's say you're buying some items, you always try to look at the reviews, right? So this is exactly what our topic has to do with today, right? So when you have a weak learners, and if you combine them, probably it give you a perception of a strong learner, and not a perception. In machine learning, it's a reality, right? So when I say ensemble, probably it's a smarter, more accurate predictions that you what you get. So machine learning borrows this simple same principles. Instead of trusting a single model, what we do is we will build a multiple weak models and combine them into a strong one, and that's what you mean by an ensemble. So today's topic that has been given to me for next probably 1 hour or so, what we're gonna do is we're gonna touch upon the ensemble learning, right? So that's a basics. So what is the goal of a supervised learning? I think you already went through the unsupervised learning and supervised learning and everything. So basically, the goal of the supervised learning is to minimize the probability of model prediction error on future data. That's what you expect. And there are two competing, methodologies. One is you build a one really good model, right, which is a traditional approach. That means you need a lot of computational powers, you need a lot of training data, and your model has to be as complex as possible, but it has to be the best one, right? That's a traditional approach. And today, what we are using, what probably industry is using, a lot of computations are using is build many models and average the results. And that's what you mean by the ensemble learning, right? So that's a more recent one. And today we're gonna touch upon that ensemble learnings. Now, this is the philosophy Occam's razor, right? One should not increase beyond what is necessary. The number of entities required to explain anything. That means the complexity has to have a threshold. It should not go beyond that threshold, right? So infinitely many models can explain any given data set, but it has to be as small as possible, probably. So let's look at these two functions. Very interesting. Again, some of you need to answer. Can you tell me what's the difference between these two? One is the f1 of x equal to sine x, and another one is the the long functions that you can see, x minus x cube upon 3 factorial plus x raised to 5 upon 5 factorial, and alternate minus plus, and the odd power to x and divided by that factorial. Can you write down something? What's the difference between these two? Yes, you can write in the chat window if you have that opportunity. Hmm, fine, great. So basically, both the functions are same, right? But they have been represented in a different way, right? Both the functions are same. So this is what I said earlier, like the simplicity is always better than the complexity, right? So exact approach will try to find an optimal solutions. So for example, SVM that you already know, right? And even the Bayesian approach you already studied. Uh, this SVM you already know, so I'm not going into the detail. What is important is these are all the other single models, right? And they have some, some benchmark performance for specific things or specific use cases. These all are the individual models. We are not touching upon those individual models right now. Now, what is the ensemble philosophy? Let's start with that. So build many models and combine them. Only through averaging do we get at the truth. That's what the philosophy is, right? It is too hard to build a single model that works best. So for example, if you try to build a single model which work in, let's say, all the cases, probably it's not next to impossible task. You need a lot of computational power, a lot of data for training, and even the model is going to be a complex, right? So there are two types of approaches here. One is model that don't use randomness, and the second one is model that incorporate randomness. Now moving forward, look at this diagram. Can you see this? Training data, and what we did is we have a bootstrap samples, right? When I say bootstrap samples, the meaning is that we are using the sampling with the replacement, right? Here we are using the sampling with the replacement. I will explain that also. So what you have is you have a sample data which has been created, like this is, if I say this is the S1, this is S2, and this is, let's say, S3. So those samples we have created out of the training data, and there are base learners, right? So there could be model 1 over here, there could be model 2, there could be model 3 over here. And you will try to do a prediction. So if it is, let's say, a binary classifications, the answer could be, let's say, in yes and no, right? If it is related to some values, probably you are getting some values, and finally you need to find out an average if it is a regression problem, right? So here you are getting a binary classification, either the answer is in yes or it is in the no. If you look at this, the majority, if we go for a voting kind of things, let's say majority is yes, then finally the ensemble prediction is going to be the yes, right? So what we did here is we have taken training data, we did the sampling, we have tried to train each model with the different samples of the data. That's very important, right? So you are not training the model with the same data. You are trying to train the model with the different data. Let's say my model could be the same here in all these things. For example, it's, let's say, decision tree, right? So we are having decision tree at here, we are having decision tree with the learner 2. But what we are doing is we are trying to train each decision tree with the different data set. And then based on this base learners, we are getting some predictions. And based on that, we are doing an aggregation over here, right? So this is what you mean by the ensemble learning. So basically, ensembles are effective because they address these three key challenges in the machine learning. The first challenge is the statistical problem, right? When the set of possible model is too large, you have a lot of models available, and right, so multiple models can fit into the training data well because you also have a data. Now it's quite possible that a learning algorithm might pick just one of them, right? There are many models, so it may get set into one which may not generalize well, right? So ensemble reduces this risk by averaging across multiple models. This is the strength of the ensemble. Second one is computational problem. As I mentioned already, in cases where the algorithm cannot efficiently find the optimal model, ensemble learning mitigates this by combining several approximate solutions. So this is the second problem that it's trying to handle. And the third one is the representational problem. If the true function is not present in the set of the base learner, let's say you have a, for example, you got a linear model, right? And actual target is, let's say, sinusoidal functions, which is not present in the base learner, right? Then there is a problem. So if you go into the detail, you will come to know that every learning algorithm has some hypothesis space. Now, what is this hypothesis space? Is the set of function it can represent. So sometimes the true underlying function we want to approximate is not there in the hypothesis space at all, right? I already given an example. So basically, in order to construct the ensemble models, before I will go into the types, there are two ways. One is the independent and another one is the coordinated. So if you talk about independent, you have to train the models in a parallel. And if you think about coordinated, you have to train the model in a sequence, right? So here in independent, randomness ensures the diversity. In coordinated, what happened? You are considering the error made by the first model. We will go in the detail, right? So each model try to fix the previous error. And in independent, you combine by averaging or a voting. And here in a coordinated, what you do is you do something like weighted sum. And the example of the independent are like begging and random forest. And here you may have a ADA boost or gradient boosting, right? Those are the examples. So the these are the main things in the ensemble learning. The first one is begging. Now, begging stands for bootstrap aggregations, right? So if you look at here, the begging came from this bootstrap aggregating. What it does basically, it creates the multiple data sets by sampling with replacement from the original data. I will explain you the sampling with replacement with one example, right? So that's what you mean by bootstrap sample. So if we have, let's say, 1,000 samples, right? And we want to create, let's say, 10 different data sets. So in each data set, we want to ensure, let's say, 100 samples. Now, when you go with sampling with replacement, there are chances that few data are repeated in each sample, and there are few data that you also missed out, right? So train separate model on each data set. Models are trained independently in parallel, and what you do finally is it combines all the output. So you do average for regression and majority vote for a classification. Now the question is why it works. Single model like decision trees are unstable, which has a high variance. I will explain you what I mean by the high variance. I hope probably you must be knowing it, but still I will touch upon that. And small data changes, it's very different trees. And begging reduces this variance by averaging prediction across multiple models because we have multiple models. And so the result is more stable and reliable predictions. Now, let me explain you it. Look at this. What is sampling with the replacement? As I mentioned you, let's say you have original data set of size n. And to create a bootstrap sample, you randomly select n items from the data set. Right now with replacement, what you do is after picking an item, you need to put it back. So if you look at this example, let's say we have original data set with the 5 items A, B, C, D, E, right? And then we want to create a first sample with a bootstrap. It's quite possible that we will get A, then double C, D, and B. Here what is happening is C appears twice and E is not selected at all, right? Similarly, if you go for with a second sample, B appears twice but C is missing. So this is how you do bootstrapping, right? This is how you create the samples. So this is how bootstrap sample is of same size, and this is what you mean by the sample with a replacement. So after doing that, this is an example how the begging works, right? So you have a different subsets of the training data set. How to create this data set I already mentioned here. You are doing it with replacement. So you have created the, let's say, 3 samples, for example, and you have a 3 base models, right? Now, these base models could be any let's say it could be SVM or it could be, let's say, decision tree as well. What you do here is, if it is the regression problem, you will do average or you can find out a mean here. Or if it is by a classification problem, probably you will go with a majority of voting. And then finally you will come to the prediction. So this is how the begging works, right? Another techniques, another ensemble method that you have is called the boosting. What it does basically, it builds the model sequentially, not in the parallel. Like here you have seen that the models are trained in a parallel, right, with data sets. Whereas in the boosting, they are not trained in the parallel, they are built sequentially. So each new model focuses on the mistakes of the previous one. So whatever the mistakes made by the model one, right, it would be corrected in the second by the second model. So those mistakes would be taken care. I will explain with a diagram as well. So misclassified samples are given higher weight. So subsequent models pay more attention to the hard cases. So whenever the first model has made a mistake, it would be highlighted. And final prediction is a combination of all weak learners. So there could be question why it works. So a single weak learner has a high bias, right? So for example, you must be knowing that the decision tree has a, you know, what you can say is it has a low bias and high variance. But when you say a single weak learner, it has a high bias. Now, by combining many such learners sequentially, each connecting the last, the bias decreases. So boosting is very powerful at improving the accuracy. Let's look at this diagram. I hope the diagram is visible. Yeah, great. 1, 2, 3. Okay. I hope somebody is listening, right?
Yes, sir, it's visible.
Okay, great. So if you look at this diagram, what we are doing here is on the first sample, we are giving it to the base model, and then base model do some predictions. Then it will try to see what is the errors, and those errors get higher weight before it goes to the model 2, right? I will show it by diagram how it will give the higher weight as well. Then it will work on that data. Again, model 2 will try to do the predictions. Now, whatever there are mistakes made by the model 2, it would be highlighted because it get high weight, so that model 3 get more attention to work on those cases, right? So basically what we are trying to do is in every run, every model is trying to improvise the error made by the first model, and that will happen in the sequence. So finally, when you come to the prediction, it has a more accurate result. So we have some, example. I have some example as well. I will show you that. But first, let's look at the third kind of things. So basically, I mentioned here, if you look at this slide, right, the first one is the begging, the second one is the boosting, and the third one is, staking, right? What it does, staking. It combines the model of different types. Now, if you look at the boosting and begging, we have probably the homogeneous model at each level. So each learner have a same kind of models, right? But in staking, what we do is each model is having a different kind of models, right? Each learner is having a different kind of model. So for example, with model 1, you can have a decision tree. With model 2, you may have a SVM. With model 3, you may have a neural networks. So each base model is trained independently on the dataset, and their prediction becomes new features, right? And finally, rather than voting or rather than, let's say, doing an averaging, you have a meta model, which is very important concept in the staking, which learns how to best combine those predictions. So the prediction was given by a different model, and that has to be combined by something called a meta model, right? So look at this diagram. This is how the staking works. So you have a different data set. The important here is you have different models, right? And finally, you have meta learner. So here we are not using the functions like voting or something like that. You have a meta learner, which is again a model. And what is the input to this meta learner is the different predictions from here, right? And finally, you will get a predictions. So this is how the staking will work. So basically, there are three things we talk about, right? And let me explain you the model error. So if you look at these things, the error emerging from any machine model can be broken down into three components mathematically. So following are the three components, right? If you look at any error, so it could have a bias, it could have a variance, or it could have an irreducible error, right? Now, bias error is useful to quantify how much on an average are the predicted values different from the actual values. So this is what you mean by the bias. High bias error means we have an underperforming model which keeps on missing essential trends. So probably when we say that the bias is more, right, probably it's far away from the target. And when you say variance on the other side quantifies how the prediction made on the same observation different from each other. So when you say a high variance model, it will overfit on your training population and perform poorly on any observation beyond the training. So overfitting will probably result into the high variance. And the objective of the ensemble learning is to minimize the bias and the variance. So basically what you try to do is you try to do a low bias and low variance, output. So if you look at this diagram, here you can see that in the first you have a low bias and low variance. So your prediction is very close to the target, and even they are not separate, they are very close to each other. Each prediction is very close to each other, right? But when you look at the low bias and high variance, you can see that it might be a close to the target, but each predictions are different from each other, right? And when you say high bias and low variance, you can see that the prediction is away from the target. Prediction is away from the target, but they are very close to each other, right? So variance is low, but the bias is high. And when you say high bias and high variance, you can see that all the predictions are very far away from the target and they are away from each other as well, right? So this is what you mean by the bias and the variance. Now, this is the trade-off you need to do. So normally as you increase the complexity of your model, so as you, let's say you keep increasing the number of parameters or you keep fine tuning, right? As you increase the complexity of your model, you will see the reduction in error due to lower bias in the model. However, this only happens till a particular point. Once you hit to the threshold, it goes up, right? So what you expect is a champion model should maintain a balance between these two types of errors. And this is known as the trade-off management of the bias variance error. And ensemble learning is one way to execute this trade-off, right? So if you look at this diagram, on the y-axis you have an error, on the x-axis you have a model complexity. What we are trying to do is our objective is to reduce the bias. At the same time, we need to have a minimum variance. And so you can see that this dotted line represents the optimal model complexity, right? So ensemble model will try to operate near to this optimal line. And that is how ensemble is, trying to do the trade-off between the bias and the variance, right? Bootstrap we already looked into. So this is exactly the begging you can see. So I already explained to you, but this is a more, refined diagram you can think of. So you have an original training data, and those training data are divided into the multiple data sample. And what you are doing is you are having a multiple, classifiers, and finally you are combining the output, and that's what you mean by the begging. So this is what you do in the begging, right? And you can say that the random forest is an example of the begging. So in random forest, what happen is a type of supervised machine learning algorithm based on ensemble learning. That's what we have discussed about, right? And what we do here is random forest algorithm combine multiple algorithm of the same type, right? So at all model here, it has the same type of algorithm, C1, C2, C3, right? Same type of algorithm. And that's the reason, so it has a different trees actually. And that's the reason the name is the random forest. And the random forest algorithm can be used for both regression as well as classification task, right? And how it works. So what it does basically, it will pick the n random records from the data set, build a decision tree based on the n records, choose the number of trees you want in your algorithm and repeat the step 1 and 2. Now, in case of regression problem, what you do is for a new record, each tree in the forest predicts a value y, right? So you try to predict an output. The final value can be calculated by taking the average of all values predicted by all the trees in the forest. And if it is a classification problem, what you do is basically it right, new record is assigned to a category that wins the majority vote. So it is based on the voting if it is a classification problem. This is what the example of majority of voting. You can see here we have an X data set, right? What do you do in the random forest is you go ahead with N1 features and the sample data, and you try to have a tree one, right? Then you go with N2 features, right? So you may have some features over here, you may have some features over here, some features might be repeated as well, and you try to construct the tree 2, tree 3, and let's say tree 4. If you observe clearly here, the tree 1 and tree 4 are saying that they are class C, right? So and others are class D and class B. So when you go with majority voting, the final class that you will get is the C. So that's how it works for the classification problem, right? And if it is a regression here, then you will go with a all of average. Now in boosting, so the earlier part that we have talked about is about the baking. Now in boosting, which is the second thing, right? So there are three things in the ensemble learning. One is the baking, another one is the boosting, and the third one is the staking. Now in the boosting, algorithms are set of low accurate classifier to create a high accurate classifier. That is what the objective. So what we do is low accuracy classifier offer the accuracy better than the flipping of a coin. So when you toss a coin, the probability is 0.5. Here, let's say it could be 0.55, for example, right? This is done by building a model from the training data, then creating a second model that attempts to create the error from the first model. As I mentioned earlier, in the baking, we will train all the models in the parallel. In the boosting, we are doing it in sequence. So if you look at here, right, these are the three main boosting models that you have. One is the extreme gradient boosting, and this is heavily used on the Kaggle platform, XGBoost, right? Then you have a gradient boosting machine algorithm, and finally you have AdaBoost, which is an adaptive boosting. So these all are the three boosting models that you have, right? How the AdaBoost work? So we will not touch upon the first two, but let me explain you this AdaBoost without going into the details of the mathematics. So initially, AdaBoost selects a training subset randomly. So you have a large training data and it will select the subset of it, right? Then it iteratively trains the AdaBoost machine learning model by selecting the training set based on the accurate prediction of the last training. Then it assigns the higher weight to wrong classified observation. So for example, you after first model, you already have some classification. What it does is whenever there is a wrong classification, it will give a high weight, right? And assign the weight to the trained classifier in each iteration according to the accuracy of the classifier. So if you look at this diagram, you will understand more what it does basically. So you have an original data set D1, you do iteration 1, and you have prediction on same training data D1, right? After that, it will update the weight and it goes ahead with the training data set of 2, right? And then model 2 will try to predict. Now, whatever the errors you see in the prediction, according to that, the weight will be updated and it would be again go to model 3. So let's take an example. If you look at here, let's say this is the first sample. And after the first iteration, for example, you have this kind of classification. So in this, you can see that on the left hand side, there are 2 plus, but on the right hand side, these 3 plus are mistakenly categorized into the minus. Hello, I hope you are able to see the screen. It's really tough. I know that it's 6 o'clock and you have screen on.
No.
How many? Okay, great.
Yes, sir. It was visible, but now your presentation is not visible, right? Yes, sir. Now visible.
Yes, sir. Now it's visible.
Okay, great. Thank you. So at least some of you are watching. Great. So if you look at this diagram, I am trying to say that, uh,
Sir, actually
yeah,
all are muted. So they are not responding.
Sir, we all are attending. Don't
okay,
worry, sir.
great. Thank you. But I assume that I'm alone in the classroom and I'm speaking. That's how it's go, right? After six.
No,
Great.
no, no, sir.
Yeah, fine. So if you look at this
So members are
diagram,
muted.
yeah, I think we are here. Okay, thanks. So let me continue now. So I'm saying that in this diagram, the plus that you can see here, 3 plus, are mistakenly put in the minus categories, right? So what second cycle they will do is they will increase the weight of those 3 plus before it goes to the model 2. So you can see the plus sign is little bit highlighted where we try to give them a more weight, right? And after that, if you look at the second model iteration and you see this classification, now here you can see that these 3 minus are mistakenly in this plus part, right? So when it goes to the third iteration, this minus will be given a more weightage, right? So that the third model have a chance to work on that. And when you do that, probably you can see here, right? This 3 minus got more weight, and even you can see this plus 2 plus are at wrong place, right? And this 1 minus is at wrong place. So after doing this many iteration, finally what is coming out is this one, right? So now you can see almost every the data has been put into the right category, right? And it has been trained so fine that sometimes it does overfitting, right? And because of that overfitting, there could be a problem. So this is how your ADA boost work basically, right? But there are a lot of mathematics and you can definitely go into the detail, but you know that how the Python support it, so directly you can use it. But this is the approach taken by the ADA boost, right? So if you look at here the comparison, so if we have a single iteration, right, this is what happened as you can see in the first diagram. And in baking what we do is we have a same kind of model, right? Simple data and same kind of model, and finally you are aggregating the result. In the baking, I already mentioned you, if you have a classification problem, you go with a voting, and if you have a problem which is related to regressions, you may take an average or something like that, right? Similarly in the boosting, what you can do is here what we are doing is we have a data and then it goes to the model 1. I already mentioned you that whatever the prediction error that model 1 will make, it would be corrected by increasing the weight. And then again you are going with the model 2, again the same things will happen. So in boosting we go with a sequential, right? Whereas in baking you go in the parallel. Now the third one I already mentioned you, it's staking. Now what happened in the staking? Now staked is a generalization, or staking for short is an ensemble machine learning algorithm. Again, it's a third approach. It involves combining the prediction from multiple machine learning models on the same data set, like baking and boosting. But what staking address the question is, given multiple machine learning models, as I mentioned you, in baking and boosting, probably you have a homogeneous model, you have the same kind of models. Here what you have is given multiple machine learning models that are skillful on a problem, but in different ways, how do you choose which model to use, right? So this is exactly the trust part comes, and that is where the meta model is playing a big role here. So the approach to this question is to use another machine learning model that learns when to use or trust each model in ensemble. Unlike begging and begging, in staking, the models are typically different. That's what I said. For example, right, I already mentioned you in begging or boosting, you have a same kind of model, but here not all the decision tree and fit on the same data set instead of samples of the training data set. So unlike boosting, in staking, a single model is used to learn how to best combine the prediction from the contributing models. Here what we are doing is model that correct the prediction of a prior model. So look at these things. The architecture of staking model involves two or more base models, often referred to as a level 0 models, and a meta model that combines the prediction of the base model, referred to as a level 1 model. So basically at level 0, what we have is we call it as a base models, and level 1, whatever you have, we call it as a meta model. So if you look at here, this is basically the staking diagram, right? So on the left hand side, you have a training data, you have a model 1, you have a model 2, and finally you have model 3 and model 4. Now this is very important. So what you have here is the new training set for second level model, which is consisting of predictions from a first level model. So as an input to the second level model, you are not giving the data, but you are giving the prediction of these models, right? And based on that, the final predictions will happen. This is what you mean by the staking, right? So the staking is the third approach in the ensemble learning you can think of, and the meta model is trained. This is finally the second level model is actually called the meta model, right? This is called the meta model. And so what is happening here is the meta model is trained on the prediction made by base models on out of sample data. That is, the data not used to train the base model is fit to the base model, and predictions are made. And these predictions, along with the expected outputs, provide the input and output pairs of the training data set used to fit the meta model. So the output from the base model used as input to meta model may be real value in case of regression, and probability values, like value class labels in case of classification. So this is what is input to the second level model. That's what we are trying to say here in staking. The important difference between, the bagging, boosting, I already mentioned here the different models you are using. And then you have a new training set for second level model consists of predictions from the first level. So you are using predictions over here, and it goes to the second level model. And finally, you have a final prediction. And these are the, examples, and you can say the comparison. So this probably will give you a whole idea what we have discussed till now. So as I mentioned you, the same algorithm, if you are using what we call is homogeneous ensembles, right? And if you are using different algorithms, we call it as a heterogeneous ensembles. So if you are going ahead with homogeneous, these are the examples of bagging, boosting, and random forest is also, right? And here you have a staking, and another interesting is the voting classifier. I will explain a bit about that as well, right? But when you go with a staking, I already mentioned you, for every model you are going ahead with a different algorithm. So in a base models, what you have is all the same type. So for example, let's say you have a 3 models, then all 3 are using decision tree, right? But in case of staking, what you have is one could be a decision tree, another could be SVM, the third could be a logistic regression, like that, right? And what would be the diversity source? So here what you do is random sampling of the data and features, right? Here what you do is inherent difference in the learning algorithm, right? And here the goal is reduce the variance and or bias. And here what you try to do is you combine the strength of the diverse model. So maybe one model might not be good fit for one kind of, question that we have on hand. So you are trying to complement their strength. And in aggregation method, what you do is average in case of regression, and majority voting if the problem is the classification. Now here, very important in staking, what you have is the meta learner, right? That's very important. And meta learner is again a kind of a model. It's a kind of an algorithm, right? And what is the strength here is it's very simpler, easy to implement, and stable. But if you look at here, it's a very powerful and can handle a complex patterns. Staking can handle a very complex patterns, right? And weakness is less diverse because all the models are of same, but definitely it will convert your high variance to low variance. That's very positive part about this. And it's a more complex, risk of overfitting, right? And here the asking, this is an analogy just to make it more simple, asking 100 similar students with a different notes, right? And here it is asking experts from different professions, right? So that's what you mean by this staking. And finally, what you have is something called a voting classifier, right? So voting is an ensemble machine learning algorithm, as I mentioned about the staking. So for a regression, a voting ensemble involves making a prediction that is average of multiple other regression models. In classification, a hard voting ensemble involves summing the votes for a crisp class labels from other models and predicting the class with the most votes. So basically, when you talk about the voting, you can have a two kind of things. One is the hard voting and another one is the soft voting. In soft voting, what you do is it involves the summing the predicted probabilities for a class labels and predicting the class labels with the largest sum probability. So if you look at here, so for example, a voting ensemble is an ensemble machine learning model that combines the prediction from the multiple other models. We already said it is a technique that may be used to improve model performance, ideally achieving better performance than any other single model used in the ensemble. It is similar to the staking only, right? A voting ensemble works by combining the predictions from multiple models, and it can be used for classification or regression. So the similar kind of diagram you can use to represent it. Uh, Look at this diagram. This is basically a hard voting classifier predictions, right? So what we have is, you can see here, there are different, uh, you know, models, and what they are doing is they have a different predictions, and based on the voting, what we can do is you can see that here the prediction is 1, here the prediction is 1, here the prediction is 2, and here the prediction is 1. And because it is the voting, so what we are doing basically is we are going ahead with the majority of the vote, right? So what you are doing is, out of these 4, let's say major are 3 has said predicted as a 1, so we go ahead with the 1, right? So basically what I explained to you probably in a very simple word is, in ensemble learning there are 3 things. One is begging, another one is the boosting, the third one is the staking and the voting, right? What is important is in staking and voting you have a different kind of model, right? Whereas in begging and boosting you may have a homogeneous model as well only, right? Even you can do some variations there as well, but it really depends on the kind of use case that you want are talking about. And the trade-off that you try to do is you need to have a low variance and low bias things, and that's very tricky part, as you have seen in that graph, right? Beyond the threshold it again shoot up, right? So this is what in the case of regression, this involves calculating the average of the prediction from the model. I already talked about that. And there are 2 approaches to the measure vote prediction for classification. They are hard voting and soft voting. I already speak about, right? And soft voting is predict the class with the largest sum probability from models. So if it is not a classification problem, probably you can go ahead with the soft voting. uh, I hope some of you are here. Great. Fine. So
Yes, sir.
yeah, if you have any query, we can talk about. Otherwise, probably what I supposed to say about ensemble methods, I spoke about, and I have some collab as well. I can definitely share with Pinal, and probably she can share with you. So directly you can execute and you can understand whatever I have explained. So I will share the link of the collab, and probably you can work around, right? This is how what about ensemble learning. So any things that you want to ask, you can stay here for next 5-6 minutes, and then we can conclude.
Participants, if you have any questions, you can ask us.
Ankit sir has raised hand, so you may ask question.
Okay. My screen is visible? Hello?
No, sir.
Not
Okay.
sir, right.
Okay. Let me check the question. Let me first. So they have mentioned in the chat.
Yes, sir. Are you able to see the question, or I can repeat it?
Yeah. No worries. How do you decide when begging or
If someone want to ask question, then they can raise their hand. We will allow it to speak.
So the first question that I got from the chat is like, how to decide whether you want to use the begging or the boosting, staking, right? So for example, as I mentioned you earlier, right? If your models all are, let's say, decision trees, right? Which are high variance model, basically. Decision tree is a high variance model, right? So if you train the same type of models, right, then it becomes the decision tree. Let's say we have all decision tree, and if we train it and we use in the begging as a decision tree, then probably your, what you can say is its variance will come down, right? And in case of staking, what we are doing is we have a different kind of models, right? So for example, if you have a complex problem in hand, right, where the single model is not sufficient, then probably the best idea is to go for staking, right? And if you have a very, I mean, it's not a very tough problem, right? So for example, in that case, you can go with begging. And if you are asking me about some, let's say, practical uh, cases, what you can see is, for example, you want to do, let's say, a fraud detection in a banking system, right? You can go with a random forest. So basically, random forest is a begging, right? And if you want to go with, let's say, some problem you have in, let's say, you are participating in some, let's say, competitions like, Kegel competitions or something like that. Probably there you may go with you would like to go with a staking, for example, right? And uh, let's say you want to predict some kind of disease in advance, right? Which is very complex problem, for example, right? Then we can definitely go for a staking. But if it is a lot of data available and, let's say, a kind of a prediction, right? You can go with a baking. So this is what you can look into. Right?
Hello, sir.
Yeah.
Sir, in the stacking mechanism, if there is voting stuff and if there is a tie where more than two models are giving the same vote, same number of vote, like two by two
Yeah.
models, then in the tie
Yeah.
condition, how would be the tie breaking stuff?
So basically, the suggestion is that when you have a even number of models, you cannot go for a voting, right? So the ideal case is you need to have a odd number of models only, right? Then and then you can go for a voting. Otherwise, you need to go for some averaging or other functions. But so the best suggestion or the recommendations that I understood is, when we are using voting as a final decision maker things, we have to have a odd number of models, right? Otherwise, you need to have a aggregator function as a different function. It cannot be a voting one, right? Uh, somebody asked the question like, uh, so when you have images, right? That is what you are saying. So in that case, the challenges would be like, so basically high dimensions I have, and so for images, what I know is probably the people are using CNN, right? And nowadays even the transfer learning people are using. But if you are talking about ensemble, uh, I think stacking we can go ahead with, because we can do different architecture we can use. So even when you use the model in the different architecture form, probably you get a different flavor, right? So stacking could be a good approach according to me for image classification, right?
Okay, anyone else want to ask a question? They can. So, sir, it looks like there are no more questions left from participant side. So, uh, sir, on behalf of Government Engineering College Modasa, I extend our heartfelt gratitude to you, sir, for delivering such an insightful and engaging session from the very first slide. With the help of those two questions, the session was very interactive, and we learned about the ensemble methods. And we sincerely thank you for taking your time to share your expertise with us, sir, and inspiring our faculties to look at emerging technologies with a new perspective. And we look forward to more such enlightening sessions with you, sir, in future. Thank you so much, sir, once again.
Fine. Thank you, Minal, and special thanks to Professor Pinal. She asked me before 6 months and I forgot everything, but thanks for reminding me. And thanks to Professor Prashant, Professor Anil, and all the faculty colleagues. Some of them I know probably. Thank you, everyone. Thank you. Thank you all. So may I leave now?
Sir.
Yeah. Thank you. Thank you.
Thank you, sir. We will take just a minute, participants. Please, let me see. Okay, so we have some time here, participants. So there were few questions about the assignment, sorry, not assignment, but a test regarding tomorrow and the certificate of FDP. So just a minute. Okay, so I'm going to share my screen now. Let me know if it's not visible. So this is my profile. You can see. You will have your attendance here on this FDP. This is our 8 September to 13 September FDP here. So you can view your attendance here. Then in this assessment tab, you will see the link here. So when you click here, you can see the instructions, guidelines. And when you check this and start, your test will be started. But please note that the timing for the test is from 6:30 to 7:30 p.m. only for tomorrow. So you won't be able to attend the test second time. And also it will not be available after 7:30. So please take care of the timing. And the feedback you have to provide here, it will be available by ATAL portal itself. So they will enable this feedback here. And you can see your test marks here. This will give you the marks for this FDP here. Okay. And your certificate will be available here. You can see the criteria for certificate is given here. You have to submit your feedback form. Your attendance should be 80% or more, and marks should be 70% or more. So you can download your FDP certificate from here. Due to certain reason, if it is not available, then you should wait for at least 3 days. And after that, you can contact us in a WhatsApp group. The group will remain as it is. So after for a few days after the FDP, so you can forward your queries there and we will solve it as soon as possible. So if you still have any questions regarding all this, you can ask me. Or you can leave the questions in the group also. Okay. Now we will take a break for 10 minutes and then we will start the session, second session. Okay, I can still see the questions regarding exam. Let me share my screen. Okay, so this is your ATAL profile. Okay, once you log in, you can see all your details here. Your applied FTP, your attendance, assessment. So you have to go to assessment tab. See, we have sessions tomorrow. Okay, so we will start from 2 p.m. to 3:30 p.m. There will be first session, then second and third. So this session will be only available until 6:30. We will complete like 10 minutes before, so you will have enough time to log into your ATAL portal and sharp at 6:30 to 7:30. So we will start an test exam. Okay, so you can access it here. Go to the assessment tab and you can see your FDP and your application number FDP from 8 to 13 is listed here. So you have to go to the test link tab. I hope you can see this tab here. So you have to click here. So there are guidelines here, like you have to switch off your phones and 50 questions. There are 50 questions and you will get 60 minutes. Questions will be of 2 marks. And you can see other here. Then appear. Okay. Just a minute. Yes, so test link will appear from here. You have to go to the assessment tab in your ATAL portal. After that, you have to fill the feedback here. So right now it is not available in my portal also. So it will be enabled tomorrow because it is available only on the last day of FDP. You can see your test marks here. Okay. After you attend the test, and you can see your percentage test marks here, and then you can download your certificate from here. So someone asked me to explain about exam again. So I hope all questions are answered here. I can see some queries. Yes, marks and certificates will be available after, but even if due to certain technical issues or maybe due to any reason, if it is not available, then it will be available within 3 days. But if it is still not available, you can contact us. You can put your query into the WhatsApp group created. It will remain active unless everyone is unless everyone gets their certificate, and it will remain active for few days. So you can put your queries there.